In this video, we're going to take the idea of the strength of a scatter plot a little bit further by discussing the correlation coefficient, which is represented by the letter lowercase r. I would encourage you to go back and watch video 0 for chapter 4 if you haven't already. There's some calculator settings you need to take care of in order to make some calculations. The correlation coefficient, or lowercase r, is a number that measures the strength of a linear association. It has to be a linear scatter plot that we're saying. It can't be nonlinear. This R value is not going to be accurate. It also gives us the direction or trend is either positive or negative. Now R is between -1 and 1. The closer it is to 1 or -1, the stronger the relationship. The closer it is to 0, the weaker the relationship. Now, note that 0.76 and -0.76 are equally strong. They would just have different trends or different directions. Positive 0.76 would be a scatter plot with a positive trend, and -0.76 would relate to a scatter plot with a negative trend. For the purposes of my class, I use the following classifications. If the absolute value of R, it doesn't matter if it's positive or negative, is greater than or equal to 0.75, that implies that we have a strong relationship. So positive 0.76, negative 0.76 are both strong. Positive 0.92, negative 0.97 strong. I say that if the absolute value of R is in between 0.74 and 0.50, then it is a moderate relationship. And then finally, if the absolute value of R, doesn't matter if it's positive or negative, is less than 0.50, I say it is a weak relationship. So again, R is always between -1 and +1. You're never going to see an R of 3 or an R of -17. And we'll use these rules to determine if it's a strong, moderate, or weak relationship. You can go to this website and get some more practice with the R value. You can just type this into your browser, and it'll bring up some images like we see below, just to get some practice with matching some scatter plots with their possible R values. So we look at these first 4. These are all related. I have 4 scatter plots, and there's 4 R values, and I just want to match them up. If I look at the R values, I get a positive 0.54, a negative 0.60, a negative 0.69, and a negative 0.97. First off, note there's only one positive R value, and only one of these has a positive trend. This one in the top left is the only one that's headed up. This one is headed down, bottom right is headed down, bottom left is headed down. So I know this one has to be 0.54, and we can see it's kind of moderate. I can see a pattern, but it's not very strong. Out of the remaining 3 R values, the negative 0.60, the negative 0.69, and the negative 0.97, the negative 0.97 is the easiest to spot. That's the only strong. You've got 2 moderates and a strong. This scatter plot in the bottom right is the strongest. The dots are very tightly clustered in the scatter plot. It's a strong relationship. And out of the remaining 2, the bottom left and the top right, the bottom left is the negative 0.60. The top right is a negative 0.69. This bottom left is a little bit more scattered vertically than this one in the top right. The top right is a little bit more clustered. Another set of 4 to look at is displayed here. This time I have 3 positive R values and one negative R value. I've got a positive 0.84, positive 0.74, a positive 0.30, and a negative 0.98. Note the top left is positive, the top right is positive, and the bottom right, the bottom right is positive in its trend. Only the bottom left is negative in its trend. So this had to be the negative 0.98. Out of the three that remain, I have a strong with 0.84. It's over that 0.75. I have a moderate with that 0.74. It's just into the moderate range. And then I have a weak with the negative 0.30. Well, this one on the bottom right is definitely the weakest. It's the most scattered. Not a clear trend here, clear pattern. The top right is my moderate, and my top left is my strong. The top left is a little bit more clustered than this and the top right. You can see by drawing those vertical lines through these values. The last thing I'm going to do in this video is look at how we can calculate R on our calculator. Before we get into the calculator part, once again, it's important to make sure you have a linear scatter plot. R is only used to describe linear relationships. Other tools exist for studying nonlinear relationships. We just don't cover those in this course. In our calculator, we're going to see how to calculate R and look at the scatter plot with the heights and weights of 6 people. I have heights in inches, I have the weights in pounds. The first thing to do is get your data into the calculator. Just like we did in chapter 3, you'll hit the stat button, you'll hit edit, and you'll enter the heights into L1. 61, all the way up to 68. Then we'll use L2 for the first time. I'll put my weights there. Normally, what we see first is going to be our L1 or our X/response variable, and what we see second will be our X/explanatory variable. And what we see second will be our Y or our response. That's not always the case in my stat lab. Just a tip, whatever's across the bottom is your X or your explanatory. That'll go in L1, and whatever's along the side on the vertical axis, this will be your L2. To see my scatter plot, I just hit the zoom button and the number 9. And I can see that I have a fairly linear relationship. I don't see a clear curve in my data. I draw a fairly straight line through all of these points. Therefore, it's okay to go ahead and calculate R. To do that, I hit Stat, go over to Calc, and I want to scroll down to number 8. Linear regression in the form A plus BX. Number 4 looks very similar, but number 8 is the form that we want. We'll always go Stat Calc number 8. I hit Enter to select it and hit Enter until my list populates. And I can see that my R value is 0.88. There's a strong relationship between the heights and weights of these 6 people. It's strong because the R is over that mark of 0.75. Just a quick note, if there's a strong relationship, either positive or negative, it doesn't mean there's a cause and effect relationship. It doesn't mean that one variable is causing the increase or decrease in the other variable. all it means is there's a strong correlation or strong association between the two variables. Correlation does not imply causation. All we know is that these two are strongly related, but there's not a strong cause and effect relationship necessarily.